Hello, this is Miss Paflin, and I'm going to be doing this video on lesson 1.1. So make sure you have this classwork set of notes to fill out as you're going through the video. And a way to know that you're on the correct one is it will say lesson 1.1 at the top left. That should have two S's. So this is investigation, numeric, and graphic representations of data. So as I go through this, I won't necessarily be filling out everything, so a lot of them will say explain or show your work. You will have to do that on your own, but I will be going through a little more on the first few videos just to get you used to it. Also, I will be telling you to pause at certain points and to do the work on your own. I really need you to follow these directions and actually do the work on your own, because that is the only way you will learn and get this practice so that you can be successful on the assignments, the spiral reviews, quizzes, and tests. So please make sure you pause and do the work yourself and then use the video to check your work. So the first thing is we want to look at the success criteria, the I can statements. So in this activity, you will, as I read through them, we're going to circle the verbs and underline the nouns. And this just helps you get a better idea of what you need to make sure you understand and know at the end of the lesson. So I can use units to understand and interpret problems. I can choose and interpret an appropriate scale for a graph. I can interpret parts of an expression, and I can write an arithmetic sequence that models a situation. So that is what you need to be able to do at the end of the lesson once you go through everything. All right, first thing is I'm going to read over task 1, real world use of patterns. But before I do that, I do want to point out, so up here it says correlating learning tasks. So right now this is the guided video. You also will need to do assignment 1 and spiral review 1 with this. So this always helps you know what are the correlating learning tasks. And then the vocabulary, we have sequence, common difference, consecutive terms, expression, and variable that you will be seeing throughout this lesson. So for the first set of problems, you're going to be using this real world problem. So Meising spent his summer vacation traveling cross country with his family. Their first stop was Yellowstone National Park in Wyoming and Montana. Yellowstone is famous for its geysers, especially one commonly referred to as Old Faithful. A geyser is a spring that erupts intermittently, forcing a fountain of water and stream from a hole in the ground. Old Faithful can have particularly long and fairly predictable eruptions. As a matter of fact, park rangers have observed the geyser over many years and have developed patterns they use to predict the timing of the next eruption. So you're going to be answering the next few questions on this page about this data that is given in this table. So I want you to pause this video and I want you to answer numbers 1 through 3 on your own. And then you will come back and continue watching the video after you do numbers 1 through 3. So go ahead and pause now. All right, now you should have done 1 through 3 on your own. So I'm going to go over them so you can check your answers. So looking at the table, number 1 says describe any patterns you see in the table. So there's really no wrong answer to this, but I just pulled out a couple important things that will help you with this lesson. So what I notice is we have the length of eruption in minutes, and I notice that these are all increasing by 1. So I like to draw arrows in between and show it's adding 1 each time. And then over here in this other column, it says approximate time until next eruption in minutes. And I notice that these are increasing by 12 minutes each time. So I notice that there is a proportional relationship between rate and time. So I notice that for every minute in the length of the eruption, it adds another 12 minutes until the next eruption. So that's a proportional relationship. All right, number 2, why might it be important for park rangers to be able to predict the timing of Old Faithful's eruptions? So just some things to keep people safe would be one thing to know when the next eruption will be. You want to keep people at a safe distance so that the eruptions do not harm them. Also, there's a lot of people who visit, a lot of tourists who visit and want to see Old Faithful Geyser erupt. So it's also a good way to let people know when the next eruption will be so that they can view it safely. All right, and then number 3, if an eruption lasts 8 minutes, about how long must park visitors wait to see the next eruption? Explain your reasoning using the patterns you identified in the table. So there's a few different methods you could have used, and if you didn't do these, there's also more. So as long as you got 130 minutes for your answer, you are correct. So one strategy you could have used is to continue the table. So I saw that it left off at 4 minutes was 82 minutes until the next eruption. So I just continued that pattern. I kept adding 12 minutes until I got to 8 minutes and saw that it was 1:30. You can also use repeated addition. So I knew that at 4 minutes, it was at 82 minutes until the next eruption. And to get to 8 minutes, I needed to add 12 4 more times. So 82 plus 12 plus 12 plus 12 plus 12 equals 130. Or you can use multiplication. Since I added 12 4 times, I can also multiply 4 times 12, which also gives you 130 minutes. Something else you need to be wary of is always read carefully. It says explain your reasoning. So I'm not going to write my reasoning, but I would want you to also explain what method you used and why and how you used it. So you will have to do the explanations on your own with this. All right, now I want you to pause the video again, and I want you to do number 4 through 5. So number 4 is graph the data from the table, and then do number 5 on the back of this sheet. All right, you should have done number 4 and 5 already. So since it just says to graph the data from the table, I just graphed 1 through 4. So always be careful and make sure you read what the directions are for graphing. So at length of eruption would be this first column, that's your x-axis. So those are so at 1, it was then 46 for approximate time until next eruption. So these are your x column, this is your y column, y-axis. So at 1 minute, it is 46 minutes till the next. At 2 minutes, it goes up to 58 minutes until the next. So you're going, always starting from your origin here, which is 0, 0. So if I start from my origin, I would go over 1 minute for the x-axis, up 46 for the y-axis. Then I go back to the origin, I go over 2 minutes, I would go up 58 minutes. So that is how you graph. X first, then y-axis. And it's the same over here, the x-axis comes first, then the y-axis. All right, number 5. Is asking you to reason quantitatively. Mising and his family arrived at Old Faithful to find a sign indicating they had just missed an eruption and that it would be approximately 2 hours before the next one. How long was the eruption they missed? Explain or show with math how you determined your answer. So for this one, it's giving us 2 hours, but all of our data is in minutes, so it would be helpful to convert 2 hours to minutes. So that would be, there's 60 minutes an hour, 60 times 2 is 120 minutes. So for this, you could have continued the table that we were referencing on the first page. So you could have just kept adding 12 until you got to 118 minutes. On here, I showed the repeated addition. So I knew that the first minute was 46 minutes until the next eruption. So then I just continued adding 12 until I got to 118 minutes. So since this was the first minute, and then so this would be 1, 2, 3, 4, 5, 6, 7 minutes total. So that would be my answer. You also need to explain or show with math how you determined your answer. So this would be sufficient because I showed with my math how I got my answer. Make sure you also show the method you used. All right, so next I am going to have you pause it right now, and I want you to do numbers 6 through 7. So go ahead and pause and do those. All right, you should have done 6 and 7 on your own. So for this, number 6 says, and we're using patterns can be written as sequences. So if you notice, this is one of the vocabulary terms that was referenced on the first page. All right, so for this, you will need to use the table or graph above, write the approximate times until the next Old Faithful eruption as a sequence. Explain or show with math, this should say, how you determined your answer. So I just went to the table, and on the right side column where it says time until next eruption, I just started with 46, next one in the sequence 58, comma 70, comma 82, comma, and then just dot, dot, dot to show that it could keep going on forever. All right. 7, how would you describe this sequence of numbers? So once again, this vocabulary term. So what's happening between each number, 46, 58, 70? Well, it is adding or increasing by 12 each time, and it also starts at 46. All right, now I'm going to have you pause it again, and I want you to do numbers 8 and 9 on your own. So go ahead and pause it and do 8 and 9. All right, welcome back. So it says in the table, 5 and 8 are consecutive terms. So this is another vocab term that was listed on the front of the packet. Subsequences have a common difference, also another term, between consecutive terms. The common difference between the terms in the table below is 3. So look at the sequence it gives you, 5, 8, 11, 14, and these are also shown here. Notice how 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. So this would be our common difference. It's adding 3 at each time. It's a common number. Every time it's adding 3. And that's the difference between them, 3. So 8 says, identify 2 consecutive terms in the sequence of next eruption times that you created in item 6. So going back to item 6, 2 consecutive terms, so I just put a couple here, so you just needed to do 2 of them. So I said 46 and 58. I said 70 and 82. You also could have put 58 and 70. So numbers that are consecutive, they're right next to each other, one after the other. And then for number 9, the sequence of next eruption times has a common difference. Identify the common difference. Well, that was something I had gone over on the first page. They all are increasing by 12 minutes in between each one. 46 to 58 is adding 12. 58 to 70, adding 12. 70 to 82, adding 12. So the common difference is 12. All right, last time to pause the video, you're going to do number 10. So go ahead and pause the video, read over number 10, and do those. Okay, welcome back. You should have done all of number 10, A through D. Last problem we're doing. So it says each term in the sequence above can be written using the first term and repeated addition of the common difference. For example, the first term is 5. The second term is 5 plus 3. So like 8 is 5 plus 3. The third term can be expressed as 5 plus 3 plus 3, or 5 plus 2 times 3. Similarly, the terms in the sequence of next eruption times can also be written using repeated addition of the common difference. Scoop this up. So A is asking, it says, write the approximate waiting time for the next eruption after eruptions lasting 4 and 5 minutes using repeated addition of the common difference. So using the example that they give you for this table, I just followed that pattern. So for 4 minutes, we know that the table started at 46. At 1 minute, it was 46 minutes until the next eruption. So that was the first minute. So if I need to get to 4 minutes, I need to add 12 3 more times. So I did 46 plus 12 plus 12 plus 12. You can also write it using multiplication to show that repeated addition. So that would be 46 plus 12 times 3, because if you notice there's 3 groups of 12 here. 5 minutes. Well, I would just rewrite what I wrote for 4 minutes, but 5 minutes would be 1 more minute. So I would need to add 1 more 12. So notice how this is the first minute, and then second, third, fourth, fifth. Or you can show that you're multiplying 4 groups of 12, so 46 plus 12 times 4. All right, B, model with mathematics. Let N represent the number of minutes an eruption lasts. Write an expression using the variable N that could be used to determine the waiting time until the next eruption. So expression is another one of your vocabulary terms. So the difference between an expression, and variable is also another one. An expression does not have an equal sign. So if you ever get confused between expression and equation, expression does not have an equal sign. And then the variable is a letter that represents an unknown value, so that would be N in this case. So the equation, there's a couple different ways you can write the equation. For this, you can write 46, so that's our first minute given. We know it's adding 12 each time, so I put plus 12. But I have to include N minus 1 in parentheses because I need to subtract the first minute. Since 46 is already included in my expression, I have to then subtract N minus 1 because I need to take away this first minute. So if I expand this out, remember, using the distributive property, I need to multiply 12 by everything inside the parentheses. So 12 times N is 12N, and then 12 times negative 1 would be negative 12 or minus 12. So this is what I'm doing. I know that I'm multiplying all of my all of my amount of minutes that the eruption was. I have to multiply that by 12. So it goes back to what we did up here. So like for 4 minutes, I would put 46, that's this first term, and then I'm adding 12 3 times, or doing 3 groups of 12. So then I would do 3 times 12 in this case. But then I have to subtract a 12 because I already included the 46 the first minute. So this is one equation. Something else that you could do is going back to the table. If I want to get rid of this first minute, this minus 12. So what you could do is actually do 46 minus 12. So I'll show you in the table. So even though if the eruption was 0 minutes, like it would really make sense to have 0 minutes logged on here. But if we work backwards, so like 4 to 3, I'm subtracting 1. 3 to 2, 2 to 1, I'm subtracting 1. So I go to 0. Same thing here. If I work backwards, 82 minus 12 is 70. 70 minus 12 is 58. 58 minus 12 is 46. So 46 minus 12 is 34. So this would be technically my starting point at 0 minutes. So, and it shows in this equation, if I did 46 minus 12, I get 34. And then I'm multiplying the number of minutes by 12. So all 3 of these expressions are correct. Now check the accuracy of your expression by evaluating it with N equals 2. So I'm just going to use the first expression that I went over. So you would just plug it in. 46 plus 12, 2 minus 1. All right, using PEMDAS and distributive property, I first need to do what's in the parentheses. So I'm going to rewrite everything else. 2 minus 1 is 1. 46 plus 12 equals 58. And if we go back to the table, we can see that when N equals 2, the approximate time until the next eruption is 58 minutes. And go ahead and test it out with these other equations to make sure that those also yield the same answer. D, use your expression to determine the number of minutes a visitor to the park must wait to see another eruption of Old Faithful after a 12-minute eruption. So let me try a different expression. So let's do the 34 plus 12 times 12. So using PEMDAS, we have to do parentheses multiplication. So 12 times 12 is 144. I still need to add 34 to that. So 34 plus 144 equals 178. And do just one step per line. Keep it organized and legible. And then go ahead and test out the other equations, see if you get the same answer. All right, this concludes this lesson for today. You will also be doing assignment 1 and spiral review 1 with this. Keep in mind that assignment 1 also goes along with lesson 1.2, so you do not need to do all of it, but I would at least start on the ones that match the same concepts of this with the vocabulary terms. So thank you for following along with me, and make sure you ask me any questions, whether through email or anything, if you need a little more explanation on anything.